And welcome everyone to our weekly call. Hope you all had a fabulous weekend. As you'll be aware, the main sort of content for our call today is going to be a panel discussion, which we'll get onto in a moment, and then time permitting, there'll be a couple of other things we'll pick up, but we'll see if there's time after the panel discussion before we get into those. So what I would like to do is just to tell you who's going to be on the panel, explain the format, and then we'll get straight into it. So in alphabetical order of their organization, which seemed as random a way of doing it as any, our panel this week includes Anestis from AT&T, Ólafur from Cloudflare, Corey from Quad9, and Gianpaolo from Vodafone. And the plan is that Corey is going to kick off, and he's going to talk about some of the sort of learnings that Quad9 have accumulated after the last several years in deploying various flavors of encrypted DNS. So just learning from sort of some deployment challenges, how it's scaled, etc. So I think Corey's presentation will take maybe 10-15 minutes. Then I'll bring in Anestis, Ólafur, and Gianpaolo to see what sort of different sort of learnings they may have, or what commonalities they have with the observations from Corey, and then we'll gradually broaden out the discussion. So if along the way you've got sort of comments or questions, use either the Zoom tool to raise your virtual hand, or put anything in the chat. And then as we get time, I'll then either bring you into the call or read out your points in the chat as appropriate. So that's the plan. We'll see how it goes. I'm sure it'll be extremely interesting. So if I could firstly hand over to Corey, if you'd like to kick us off, and we'll see where the discussion takes us.
Sure. I don't do a lot of Zoom calls, so I'll have to figure out the sharing and whatnot, but it should work. I think I can do that. Share, does everyone see slides at this point, I suppose?
Yes.
Yep, that's worked perfectly.
Okay. All right, great. Okay, anyway, just a general introduction. I'm Corey Mosher. I'm the CTO at Quad9. I'm one of three co-founders, John Todd, who everyone knows, being one of the others, and Danielle Deibler, who I think has also joined the call, is our Chief Security Officer and General Herder of Cats, being another one. In any case, this presentation is going to be a bit low level for most of you, since, to be perfectly honest, it's really targeted at two audiences. Number one is obviously people who are in the space, in order to encourage the discussion for the panel discussion as well as later here, but also for anyone who isn't yet doing recursive DNS and is interested in doing so, or honestly wants to expand their DNS offerings, essentially saying, here's how we, well, I think, maybe, I don't know. So in any case, right into it. So there's honestly been a number of challenges with the DNS in recent years. Complexity and growth have just been going through the roof, as I'm sure you're all aware. So, and the velocity of that change is increasing. I'm not going to spend too much time going over this. I know this is all very text heavy, but generally, we've seen encryption specifically go from DNSCrypt, early 2010s. What was that? 2012, I think. To DOT to DOH, and now DOQ on the horizon. Still not implemented a number of places, but that pace of increase has just been, picking up. As well, we've had a number of changes in things, simple things like, well, theoretically simple, like RSA certificates moving to ECDSA with, EDDSA and whatnot potentially on the horizon. Obviously, there's the whole post-quantum, discussion that's not touching on certificates specifically, but again, there's just the pace has been picking up. So additionally, beyond that, encryption by default seems like it's finally happening. Honestly, private DNS on Android was a really big deal. DDR for Microsoft's implementation for Windows 10 and Windows 11 has been out there. We were a participant in that. I know we've got a couple of other participants on the call, at least. So that, again, that pace has just been picking up, and we might quickly come to a world where encryption is, maybe not omnipresent, but certainly more ubiquitous than it has been up until now. In any case, I've got a couple of notes on here. This is more anecdotal, but certificates with IP addresses, especially IPv6 addresses. If you haven't done it and you're running an Anycast resolver, or honestly a resolver of any type that may be subject to auto upgrade, really you should actually use them. We recommend DigiCert. Just as a side note, they've worked out very well for us. It was certainly a challenge getting them. That's all I can say about that. But they did a great job, and we're very happy with that. So in any case, again, with the increase in all these different technologies, we've been moving from technology to technology, and there's a lot of new code. There's a lot of new and non-standard behaviors. And these basically are going to lead to a lot of new bugs as well as attack surfaces. So there's a lot to keep track of here. Everybody's familiar with just how many different DNS RFCs there are. Just paying attention to them is a full-time job for a small team, to be perfectly honest. And not to mention actually doing implementations, doing reference implementations and things like that. The one positive about all this is that because there is a limited legacy, right? We don't have 20 years or 30 years of DNS encryption to look at. We just don't have that much of a long tail in terms of things we have to remediate using DNS flag days or other means in order to get a lot of things fixed. The TLS 1.2, 1.3 upgrade, for instance, for most browsers, DOH, you just don't have to do anything. It's honestly happening on its own. For DOT, we still see, I think, about probably 1/3 of our traffic is still TLS 1.2, but we think that will change over time. So DOH is TLS 1.2 is very minimal. I think 1/32 of our traffic is 1.2 still. Anyway, regardless of all that, that means there's opportunities for even small entities such as Quad9 in order to effect a lot of very positive change in the industry. We can help a lot of people do a lot of good things very quickly because of all of the preceding factors, right? That pace of innovation can be negative, but it can also be very positive, and that's how we think of it. In any case, cost complexity increases for encryption, as well as the adjacent technologies, is just increasing an amazing amount. Even when we started Quad9, and I've been doing DNS for quite a long time at this point, but the days of UDP and a little bit of sprinkling of TCP are long gone. They're not coming back, and it's only going to get worse or better, but a little bit worse. So over here at Quad9, we see about 6% of our traffic on the front end is encrypted. That's continuously rising. We're probably a little bit lower than at least some of the people on this call have seen. That's probably for a number of reasons, but it just keeps going up, and it has a lot of costs in terms of technology as well as capital costs for us. You've got other things that are adjacent to encryption, DNSSEC, which from our perspective is adjacent in terms of how it's implemented, right? You've got hashing functions and whatnot, but as well as the encryption to the authoritatives are also driving, which is a large potential, but it's a large potential concern. So, DNS multipliers, DNSSEC, multipliers and amplification are of course significant, since one inbound query can turn into 130 outbound queries, and that's quite common. We tried to limit it to 70. We found that was wholly inadequate. We moved it up to 100. It's still not always adequate. In any case, the tooling and support for encryption can be limited and lagging. When DOH came out, we had there was essentially almost no testing for it. You had to handcraft queries. STIG came along in the Power DNS toolkit. We're very happy for that. DOT was always a little bit easier since it was available in things like KDIG. But to be perfectly honest, performance testing for a lot of these technologies is partially implemented, so it's very hard to get real numbers. In any case, the effects on troubleshooting, telemetry, and most importantly, support are significant for encryption. Troubleshooting, everyone here is aware with that. You just have to deal with the fact that it's very difficult to actually look and see what your front ends are doing exactly. In terms of telemetry, not necessarily encryption, this isn't client-side encryption, but you have to make sure that all of your data is protected in transit, wherever it's going to its final destination, and that it's encrypted at rest. So there are costs there, and then again, support. And I don't necessarily just mean support in active staffing terms, although that is very significant, but user education is also significant. Being able to teach people the 6 different things that they can potentially do to connect to your service has been quite a bit of a challenge for us. It's I still don't have a great answer for that. In any case, there are a number of challenges. There are a lot of opportunities. As I like to say, welcome to the edge. Our network is very much a thin spread of DNS kind of all over the place. As anybody who's familiar with knows, we are in fact a Anycast recursor, but beyond that, we are also present on a number, and again, a thin smear on a number of different providers who have essentially graciously donated, CPU, network, support, all sorts of things to us. So there are a number of cloud considerations for those who are interested in getting into this kind of model. And by the way, while we are what we call self-hosted, in terms of how we actually behave, since we're not in any of the public clouds, we do essentially function as a private cloud, especially on some of these. We're often inside of VMs that we have no control over, and things like this. So we have a number of the drawbacks of a cloud provider without necessarily getting a lot of the positives of a cloud provider. And that can mean various things. It can be difficult to get Anycast support going inside of clouds. That's why we're not in a number of the public clouds, by the way. We've tried, and being able to effectively announce inside of those is very difficult for someone who doesn't operate a backbone network, which we don't. So obviously there, the simple challenges that everybody's familiar with, split horizon, it's always going to be a bit of a challenge, especially if you're in an externally hosted environment. And then, hardware support for a number of the things I'll talk about later, which meaning encryption accelerators. Anyway, as I said, we are a bit of a traditional colo / self-hosted model, even though we are sort of a private cloud model as well. And we are currently looking, and we encourage other people who are looking to engage in this, in attempting to extend their existing hardware's lifetime by looking at systems on a chip, single board computers, or data processing units. So, for instance, the NVIDIA Mellanox Bluefield technology is very promising looking. I'm trying to get my hands on some of them in order to play around with them and see. But they're honestly, in some cases, more powerful than the computers we have deployed. So definitely an interesting thing, especially when you're space constrained. In any case, one of the other things we've been playing around with, which is Intel QAT. I mention it with a bunch of big slides here. I don't have that much to say about it, since again, this is very much in a research phase for us. Some of you may have been working with this, and please do reach out to us. I would be very interested in hearing your experience. But the CPU support for this is very limited. It's in Xeon D chips, the Atom C chips. It's uncommon in enterprise. We're very much a secondary market. We buy a lot of used equipment, so it's impossible to get our hands on things like this. So we've turned to looking at things like PCIe cards. We've picked up a number and are testing out, attempting to use some of the 8925, 8955, as well as some of the C620 based chipset Intel cards. This has been very interesting. It's very promising. And I think I missed one of the key things above there, which is that Intel QAT is asynchronous, which is huge in terms of actually unlocking a lot of the potential, for the compute platforms. One of the things we do see is that large scale encryption does tend to be very blocking, especially when you get into what I'll talk about on the next slide, which is that Intel chips specifically have a habit of downclocking and whatnot, and have a limited capacity for dealing with encryption pipelines. Anyway, for those interested in getting into this stuff, by the way, just as a side note, virtualization does have a few requirements there. Honestly, any current hardware, anything even remotely recent, VTD support and SRIOV support is required, but again, it's going to be available for anything that's been built in the last 10 years for the most part. So anyway, applicability. So this is some of my Intel notes. AVX 512 FMA units are only somewhat supported on the older chips, and a lot of people with large budgets are essentially look at this and say, oh, well, that's not a big problem. Well, it's a big problem for us and other people who can't necessarily do a full uplift on their technology. The older chips might only have a single unit. Some of the newer ones have two, but they do for the older chips have a habit of actually sending it into a halt and then power the FMA. So just something to keep in mind if you're thinking those might save you if you're doing a lot of TLS offload. Be aware there are some gotchas, especially if you're secondary market. Beyond that, I'm not going to spend a whole lot of time on this. Everyone here is aware that there is limited hardware acceleration support for anything that isn't in the mainstream. So I have concerns for the future as to in terms of a number of the our ability to keep up and widely support newer protocols, newer encryption algorithms and whatnot as they come out, because again, we just don't have a huge budget like a lot of other organizations. So we're always trying to look out for how we might be able to maintain performance. And again, future algorithm performance is not predictable. We just, no one knows what a post-quantum world is going to look like in terms of real, Cloudflare knows, but very few organizations are actually very familiar with what these are going to look like. So I'm getting a little bit long in the tooth here, so I'll try to go as quickly as I can through this. This is mostly a discussion slide. Anyway, down layer challenges. So everyone here is familiar with things like handshake cost, session resumption, things like this, things you can do to mitigate those. TCP versus UDP, for the longest time, there was nothing except for UDP with a little bit of TCP here and there. Now everything is suddenly TCP. Hopefully we can move on to DOQ as quickly as possible in order to mitigate that a bit, but it's still a concern. And obviously getting into things like packet sizes, everyone here has struggled with this, but as a DNSSEC supporting recursor, it really has been a bit of a challenge. Anyway, as for uplayer uncertainty, meaning going out to the authoritatives and various other services, including policy servers, RPZ has become huge. Metadata servers are also critical. For instance, we have a blocking technology that is, powered by things of this nature. So there are additional challenges. DNS is not simple anymore, and so you're going to go out to a number of additional data sources instead, and then send your data off to a data lake potentially. Anyway, for those who are doing this new or have been doing DNS for a while but are just getting into encryption, there is a huge uplift to be able to scale to this. There are things like acceleration support and whatnot, but the cost and availability of servers capable of supporting this can be very high. And again, post-quantum, who knows what's going to happen. And I would actually love to hear people's opinions on this call right after this. Anyway, how to scale, for those who are, again, doing this new, talk to your web guys. Honestly, most of the people who've had to do this over the years and done TLS offload and whatnot are going to be very familiar with it. DNS is a little bit different, but it's becoming less different, especially with DOH becoming so prevalent. So yeah, I'm not going to bother talking about any of the further cloud issues, but again, how to scale DNS dist. It's multi-protocol. It's very, very fast. It's extremely well tooled. It's really saved our bacon. It's one of the reasons we can keep up with the big boys, as it were. We had done a number of things by hand, as it were, before. And we're pretty much DNS dist converts. We use it everywhere for pretty much everything. So, yay. Anyway, and then, final kind of items to potentially talk about that I would be interested in hearing about here, which is, what if client encryption really takes off, especially via, DDR support in the operating systems? And, what also happens if and when existing algorithms are deprecated suddenly, right? What if the post-quantum world suddenly happens quickly? So in any case, I'm going to leave you guys with a bit of an architecture slide. It's a interesting in general, but for those of you who might be curious, I'll leave this here. Anyway, that's all I've got. I do want to say one last thing. It's because we don't get a chance to say this very much, but thank you very much to essentially the entire Quad9 team that has past and present, and as well as all of our supporters who have really made this whole thing possible. It's kind of amazing, honestly. So that's all.
Perfect, thank you, Corey. I think that's an excellent introduction, just to sort of bring in the topic and highlight some of the challenges. Now I'm going to come firstly to Gianpaolo, because I know, Gianpaolo, you need to drop off in a moment for an unexpected work meeting. So if you're still on, have you got any comments, any observations that you want to make from Vodafone's perspective whilst you're still with us?
Yeah, me very quick. So thank you for the presentation. I think you are covering all that will be the future, because we are already experimenting it. For us, is more in experimental phase. So we are serving DNS for all of our customers, still using port 53 UDP. So the old world, we are experimenting with the DOH, and the main issue is scalability, as you pointed very well. So we are thinking to experiment using graphic cards, using accelerator, but still this is an open issue, and will take time to migrate to it. So thank you.
Okay, thanks, Gianpaolo. Let's broaden out the discussion then. Corey, I think, made some sort of very interesting points just in terms of some of the issues and challenges that you've hit with Quad9. Maybe that'd be a good time then to bring in Ólafur to sort of get the sort of Cloudflare perspective, because you've sort of, I guess, been scaling similarly, same sort of period, supporting various flavors of encrypted DNS, and we're one of the very early adopters of DOH. So were there things there that resonated with you, or things that you picked up that are completely different, given you've got a sort of some differences in your architecture, I know?
Yeah, Corey's experience was very interesting. Our experience has been totally different in regards to supporting the encrypted part of DNS, because we are leveraging or already in place highly optimized platform to deal with TLS on the web traffic. So we are reusing that. And we are using modern hardware. We are lucky enough that we can afford it. We only use hardware for a few years, and we are very religious in using very recent versions of libraries and only using libraries that have a good support of the accelerated instruction sets. So some people I know in the past have suffered because they are using operating systems that don't support modern libraries or their latest versions. So that is one thing. But I would like to take a slight different approach than Corey did. We are basically talking about two things. One is how to support encrypted connections. To me, that's easy. Operating a resolver, that is really complicated. And we have to separate these two issues. Many of the issues that Corey talked about are a conflation of the two. Dealing with DNSSEC, that's normal resolver operations, has nothing to do with doing encrypted to edge devices. And to us, the biggest advantage of supporting the so-called encrypted DNS is it solves the last kilometer problem. i.e., eyeballs can get a clean path to whatever resolvers they want to talk to. Whether it's a public one, it's the one supported by the company, or their ISP, doesn't matter. It's there are too many devices on the internet or that are interfering with DNS. So getting a good DNS resolution is really hard in many places. We have seen a steady increase in the traffic that is coming to us over the years. Right now, we are well in excess of 20% of traffic coming in over TLS or DOE. We are increasing the traffic we have to authoritative over the TLS, and that is also very good. And so, in general, the part of supporting DOE and soon DOC is not that hard, but that's because we are leveraging a platform that is already doing all of these same operations. For somebody who is starting out from scratch, I can't emphasize enough. Make sure you get your good hardware, good operating system, good libraries, and build it from there. Yeah, and support the modern tools. DNS-Dist is a fabulous tool and has helped us a lot. On our resolver software, we are on a second iteration of what is our resolver engine. And we needed to, as we are now supporting multiple different resolver configurations, do not private filtering, previous company world scheme, supporting DOE and GOC is trivial compared to just operating a big resolver. One of the hardest things we deal with is when we get popular in a place where we have low capacity. Yes, that happens. But then we have exactly the same problems as Quad9, but with our big Anycast network, we can fix that by simply dropping the prefixes. Yeah, so overall, I think everybody who operates a resolver should be using and providing service over encrypted channels because it increases the overall reliability of the DNS system. That's, I think, all I want to say at this point.
Great, that's helpful. Thank you, and obviously coming at it from a different point of view, which is great. I saw a question in the chat, which was, I think, directed at everyone. So, which was to try and get a sense of what percentage of the overall traffic is encrypted versus unencrypted. I can't recall if you actually mentioned what percentage.
We're in excess of 20%. That's what I can say.
Fine. Okay, that's helpful just to get a sense of the proportion. Thank you. Great. Well, let's take the opportunity then to bringing Anestis to get the point of view from AT&T, who I think is at a much earlier stage in the deployment of support for encrypted DNS across its various network architectures. Same question really, Anestis, in terms of what you've heard from Corey and now from Ólafur as well. Do those observations resonate with you, or from what you've done so far, are you seeing different challenges, given you've got, I guess, the sort of legacy networks you need to support as you build out support for encryption?
Yeah, thank you, Andrew and Corey. Nice presentation. I think you touched a lot of the issues and points that we're working on as well. Definitely a lot of challenges because we have, AT&T has a big variety of environments, right? So we have broadband, we have wireless, we have Wi-Fi, we have wireless, different environments, 5G, 4G, and also a huge existing customer base that basically enjoying today like 100% almost availability on the resolver side. So what we do with Encrypted, it definitely support it, and we're working on it. Actually, EDDI was the form that we first announced the trial that we're running. So it's still running. We have been running it for almost a couple of years, and I think it's good because we're learning what's the right optimization to do, both in terms of software and hardware, because I think as you mentioned, a lot of these things could be hardware acceleration, but also there's a lot of opportunities for software acceleration. I think given how things move fast, software is definitely something that we can do much faster, and has a lot of impact as well. I mean, we've seen quite a bit of impact. So in terms of the one of the actually observations, obviously since we, most of the encrypted stuff is on a trial, the perspective is slightly different. So we announced it to select customers, also EDDI, as I mentioned, some other forums. So basically the perspective is whoever is privy to the announcement, right? So what we've seen there, I mean, it's interesting that we see. Actually, we're a little surprised. We saw more DOT than DOH, almost like 10 to 1. So that even though DOT is older, it seems like it's still implemented, at least for the clients that we see in our network. So I mean, obviously it has legs. Now the other thing that I think it would be interesting to share, perhaps from the perspective of uplifting, because Corey was talking about a major uplifting, and this is what we're actually doing today. We see obviously a significant cost of all this encryption. I think it's probably in the order of 5 times from the CPU perspective. And I mean, for DOQ, we haven't started yet in terms of evaluation, but I see some initial reports that are 2 times the cost of the existing DOH-DOT. So obviously, the infrastructure component is going to be huge. There are significant, I would say, challenges there. The other thing that is, I think, is important to mention with all this is, we're striving to have like the most secure network, AT&T. So one of the things that we want to make sure that we have the capabilities to have a secure experience, both from the customer, but also prevent also all this malicious stuff going on in the network, right? So we want to protect the customer and the network, and we want to do it in a way that is consistent across the different platforms. So we have obviously customers on their mobile phone. They could be 5G, 4G, or 5G evolution, or maybe they go then to their house and they're connecting to the Wi-Fi, and then they're going on their computer, which is might be on Wi-Fi or wired on a VPN. So we want to be able to have that experience sort of very, very consistent, right? So we don't want to have like latency issues. That, I mean, if it's consistent latency, then that's one thing. If it's latency that changes as you move from place to place, then that obviously becomes a problem. Overall page downloads, all they care, all customers care is like, okay, how fast does my page download? I mean, they don't care about DNS, but we're the first ones who hear the problems, right? So it becomes DNS the first point of contact, provide that experience seamless across the different environments. I think that's one of the challenges for sure. I think that's sort of our experience so far. Definitely, I think there's definitely a lot of opportunities around improving performance with software. I mean, the other thing is, so within, we do that all in our network, and it's important to have latest hardware. But as in probably most places, and especially that's a bigger challenge for definitely ISPs that support a whole bunch of different services, is that how do you do that while serving other content, other functions? We have gateways, we have other critical infrastructure. So how do we do that in a way that is also the best for all this encrypted DNS as well, right? So I think we have we have a lot of different challenges and opportunities in that space, and I think this discussion is definitely really good. I think it seems like we have the similar sort of major issues to work on, but it's also at the same time very exciting.
That's very true. Thanks, Anestis. That was helpful. Just to highlight, perhaps the challenge of working across multiple networks, as you say, giving that consistent customer experience. Just one question on that, and then I'll sort of just pick up a question from the chat as well for everyone. Where you mentioned about you're seeing a much higher percentage of DOT rather than DO, Anestis, at least currently. Do you think that would be because until very recently Android only provided native support for DOT, or was that coming not just from mobile devices but from a wide range of devices? If you're able to comment on that.
I think it's coming from a wide range of devices, probably more desktop. I mean, we haven't found out exactly why. We were just quite a bit surprised as well. So I mean, I would think since at least the invention of DO, there would be much more of that, since the applications can do that directly, right? But it seems that DOT, at least from the limited trial, is quite prevalent.
Yeah. Okay. Thank you. That's helpful. And then a question then for both you and Ólafur, because Corey's already answered it in the chat, which Chris Woods has kindly relayed from Paul Grubbs, who had to drop out. Do you support clients sending DNS queries in early data in a TLS 1.30 RTT resumption handshake? And if not, do you plan to? Which is a bit of a mouthful to read out. The actual, you'll see it in the chat. It's the second from bottom comment in the chat. So I don't know if either of you, Ólafur or Anestis, have given that any thought as yet. And if so,
we plan on supporting it. I am not 100% sure whether it is already rolled out or not.
Okay, thank you.
Yeah, we support it on the trial.
Great, thanks. And Peter, I can see you've raised your hand, and that'd be a good prompt to say others. If you've got questions, please use the Zoom tool to raise your hand or put them in the chat, as has been happening. So Peter, do you want to come in?
Yeah, this is kind of a general question for anybody. Do you see any fundamental differences between what's been rolled out so far with DOT and DOH and DOQ? Any like unique challenges?
There is one fundamental difference between DOT and DOC is that we are not going to have a blocking on queries versus in DO. On the other hand, we can use the multiple channels to answer different questions out of order. So yeah, DOC is very much more like the UDP that we are used to. So it will be very easy to support it, and we're looking forward to it.
Right, thanks. And I think Corey, you indicated, I think in your slides, you're quite positive about the prospect of supporting DOC. Is that much for the same reason as Ólafur's just commented?
Oh, absolutely. Yeah, we're currently building a trial for it. We were hoping that we could kind of wait it out and get it for free in DNS-Dist, but in the meantime, we are actually doing an implementation. I don't have a specific date on that, but soon.
Good. I should shamelessly mention, by the way, that in 2 weeks' time, so this is hot off the press, Andrei Meshkov should be coming back onto this call to share the experiences that Adguard have had supporting a DOC resolver and clients for the last, well, probably 15 or so months now. So that could be quite timely for those of you that have an interest in DOQ. Anestis, I don't know if is DOQ on your roadmap as yet, or is it still too early for you in terms of where you are with your deployment?
Yes, it's in the roadmap. Yeah, I mean, there's definitely a lot of potential there from again performance perspective. I think the one concern is the additional cost that we don't know. How do we increase our capacity? And so that's something we're actually actively working on.
Okay, thank you.
Thanks for the question, Peter. Anyone else got any questions? As I say, feel free to raise your hand using the Zoom tool. It's one of the options under reactions if you're unsure which icon to use, or pop something in the chat if you're not in a position where you can easily talk, and I will happily read it out if that is simpler. Maybe why people were thinking, perhaps just a question for each of you, a nice easy one. Based on what you've seen so far, is there anything that with hindsight you definitely wouldn't have done in your deployment, which was obvious with hindsight, but probably wasn't at the time? Again, I'll perhaps pick on Ólafur and Corey first, as you're much further out in your support with a number of years under your belt. Anything, Ólafur, which really jumps out at you from what you've learned now?
Well, when you're deploying new technologies and doing things where things are scaling up, you don't necessarily know what is going to be the problem. And so anything that we run into is, I would say, reasonable to have expected. There were some challenges we had with our logging systems. At a point, we have had the problems with the original resolver, that it was not good enough for what we needed. To add various functions has been sometimes a slight challenge, but nothing serious. So basically, if you have the hardware platform that can support the volume you're going to get, you're good. And those doing it now should have learned, be deploying software that has learned from the experiences we have gone through. So no, there's nothing we would have done differently.
Okay, thank you. That's helpful. Corey, what was your take on that?
I actually do have a fairly major item that I would have done differently. Our architecture does not support encryption at these volumes particularly well alongside normal recursive resolver traffic. That's something that Ólafur touched on, you know, where we were conflating a lot of the items, and because we are, again, very compressed and relatively small, that means we're doing everything sort of in a, you know, a singular unit. You know, one of the less popular things to say is that a number of our facilities are using, you know, less power than you know, might be present on a current generation phone, just in terms of what we have available. And the thing that I would stress to people to avoid doing, this goes into the cloud support and whatnot, is don't mix your recursive and your encryption traffic on the same processor if you can avoid it. If you've got two CPUs, one over here, and that way you can keep one CPU in you know, in accelerated mode, and the other one, like, context switching essentially kills, and everybody here is familiar with that, but I really can't, you know, downclocking and CPU halting really does kill. I know, I think Cloudflare actually put out a really good paper on it, and that we referenced, after bumping into it and being like, what's going on? Why is their performance tanking? And it actually turns out it was that, and we used a lot of their stuff for that. We're currently in the middle of attempting to re-architecture away from that, but again, the challenge with having a kind of a, you know, an uncontrolled cloud provider is we cannot necessarily pin CPUs on hardware we don't necessarily control, so it can be quite a challenge for us. So right now we're trying to move front ends and back ends far away from each other, so that even when we don't control it, we're able to mitigate the impacts. But it's quite significant.
Okay, that's interesting. Thanks, Corey. And again, Anestis, it might be perhaps too early, but yeah, I don't know.
I think that's also our sort of a challenge. Where, you know, I mean, we have a little bit of the benefit of running the trial and seeing things and then deploying. So we actually did make some changes in the architecture to basically manage capacity separately for the decryption part and the serving DNS traffic part. I think that's also something. Also, I think is sometimes, you know, you might think that, you know, okay, so you use some general decryption software. I think it's important also to sort of see if there's you know, technology that is more in tune with DNS. You know, since it's not the general web traffic, right? So, I mean, generally the packets are smaller, and then the devices that support it might be like a different set. So, so I think that's some of the challenges we had in the beginning. You know, again, you know, some of these things you learn and you evolve the architecture as you go, which is, I think, is going to be necessary.
Yes, yeah, absolutely. Okay, that's great. I'm not seeing any more questions in the chat, so I just maybe throw in one last question to Corey, just which occurred to me as you were talking, Corey. In terms of power consumption, from what you've described, I'm guessing the amount of power you're consuming has gone up somewhat over the last couple of years or so. Is that as far as you're aware, is that the case? Or given the additional processing power you're needing for the encryption?
It has gone up, but it's really hard. So we're experiencing, 2% week-on-week growth, and that's actually having slowed down, although the last few weeks has been 4%. These numbers might seem small to some organizations, but we've been experiencing them for a number of years now, and we are a very small organization in real terms. So that has been quite a challenge. So yes, we've seen power grow. And I will say encryption is power hungry. Again, when the FMAs switch over to decryption mode, they do that to gain additional power. They're actually stealing power from the rest of the CPU, and that's why you can't then overclock or have turbo mode on all cores, right? You're switching it all down into the encryption. But yeah, we definitely have seen an increase in power. I will say though that honestly, we don't feel that burden specifically ourselves, since the people who are donating resources to us typically are the ones who are kind of taking that burden. A lot of organizations, would watch their own power, but honestly, with PCH, GSL, I3D, Eduno, they're the ones who are donating that power to us, and so we don't feel it personally.
Yeah, and as you were saying, I was thinking actually, if you're seeing 2% week-on-week growth, then probably hard to separate out what the increase in power consumption is versus just increase in traffic. So attributing it will be tough. Whereas I think some of the organizations sort of listening in with more sort of stable customer base, that will be perhaps more something for them to ponder. As they need to uplift the power into their data centers to support this. But yeah, okay. Well, that's really helpful. Thank you, everyone, for coming on and sharing your experiences. I'm confident that so many people listening into this, either real time or the recording, will save a lot of wasted effort on the wrong things. So based on your knowledge, that's much appreciated. Thank you in particular, Corey, for producing the slides and walking through, so sort of going on point for this, which is always a tough gig. But also thank you to Ólafur and Anestis as well, and for Gianpaolo, albeit for then being hijacked and having to go off to attend to something in his day job partway through, which is always a joy. So thank you, everyone. I'm just going to briefly sidetrack onto a couple of other things in the remaining 3 minutes. So just bear with me a moment whilst I share my screen momentarily. Okay, so just briefly, a couple of things I'll highlight. I won't go through everything on the slides as we're almost out of time. I wanted to highlight first, those of you that are involved in the ITF's ADD working group, just a reminder that there's a document out for an adoption call which runs through to this coming Friday. This is the latest draft from Tiru and co-authors to address the enterprise split DNS challenge. If you've not had a chance to express your view whether that should be adopted by the group, please take the opportunity to look at the document and express your view on the mailing list by Friday if you possibly can.
Andrew?
Yes, Glenn.
Sorry to interrupt. Since we're talking about ADD, I'd like to, if I may, can I put a second pitch in there for everybody?
Of course.
There is another topic that Mr. Lawrence and I also threw out there around the same time we raised the call for adoption for the document Andrew just mentioned. This is around the broader discussion that we're trying to kick off around the requirements or the need or where people think the world is going with regard to the information provided by resolvers back to clients to help them make a decision. Part of the ADD charter had this vision of like this rich information data set of some sort and a means to communicate it from the resolvers back to the clients for decision making. But we've noted that DDR and DNR don't really make use of it, and some of the other things don't really go into that depth. There's been a light pass made of it by a one document so far around some policy stuff, but it's really light. And so we're actually asking for a discussion to start up of, is this still a thing that the group wants to work on? And do we need to like, revisit the charter and decide if this is still a direction the industry and the technology is going? So you'll see an ADD mailing list. We're looking for a conversation there. We do plan at ITF 114 to dedicate some time on the agenda to have that conversation, hopefully for many people in person, very high bandwidth, but of course it'll be during the session, so everybody will be included, but we want to have people have that conversation, because if it's not something we want to do, then let's update the charter and get rid of that work item.
Yeah.
Thanks, Andrew.
Good point. Thanks, Glenn. Yeah, so comments on the mailing list, I guess, on both of those in that case. So thanks, Glenn. The other thing on this slide I mentioned just very briefly, just following up from a call of I think a couple of weeks back, which is I was reminded that Cisco also offer an alternative to the discontinued Alexa Top Million list alongside the one from DNS Filter that Peter mentioned a couple of weeks back. So that's there for your use should you have a need for it. In terms of things coming up, only two I'll mention. One is current, which is RIPE 84, which is running this week, which is why some people who would have been on this call are attending RIPE currently. On Thursday, you've got the DNS working group within RIPE 84. So it's free to attend, but you do need to register in advance. So the link is included on the slide, which I'll share out later. But it's this Thursday at 1100 UTC, if that's of interest to you. So obviously one more for European time than US time, to be fair. And then finally, just a quick reminder, next week, Mallory Nodal from CDT will be joining us with a policy-focused discussion, talking about some of the legal challenges from around the world on encryption. And then confirmed just before this call, following Monday the 30th, Andrei Meshkov, CTO from AdGuard, will come on to share learning from having sort of deployed DOQ resolver and client software for 15 months, possibly more, may even be close to 18 months now. So Andrei will come on to share those learnings in 2 weeks' time. And that's it from me, as we're sort of just past the hour. So thank you everyone for your time with this week. Thank you in particular to our panel for coming on and sharing those invaluable learnings. That's really appreciated. Have a fantastic week, everyone, and I look forward to seeing you same time next week to have a very thought-provoking discussion with Mallory Nodal. So see you all then. Have a fantastic week. Bye all.
Thank you, everyone.
Yeah, thank you. Bye.
Thanks, Andrew.